Foteini. How are you?
Hello, Dora. Thank you for hosting me.
So where are you right now?
Well, I'm on my living room right now. I guess that's the best description about where everyone is right now. I'm in Washington, D.C., more specifically on the Virginia side of the greater D.C. area. And
Nice.
working from home.
Nice, perfect. So basically, this episode is about blockchain and Bitcoin and cryptocurrencies. Just a quick chat, really, because we can't really cover everything. I thought that you are an expert on this. This is why I called you on the show. Correct me if I'm wrong. Your background is cryptography and data privacy and something like that, right? So what did you study and what do you do now?
Well, my background, my bachelor's is in computer science. I got my bachelor's degree back in Greece, and then I moved to the US to do a PhD still in computer science, and my specialization is cryptography and data privacy. So during my PhD, I was working on electronic payments. So I was designing cryptographic protocols that can create privacy-preserving electronic payments. And I'm kind of an expert on that part, and this is kind of my connection to the blockchain setting. And I'm happy to elaborate more. Depends on how much you want me to talk about that part.
Yeah. So let's start. Okay, now I see how you got involved into cryptocurrencies and stuff. So, I mean, the main reason why I called you here is just to explain all of these things in simple words because it's quite difficult to understand. Even myself, I'm just studying about these things now, and I'm kind of struggling to understand what it is exactly. So this is why I called you on the show to talk about this. So what exactly is Bitcoin?
So Bitcoin is a way, is a cryptocurrency, okay? So we call it cryptocurrency because it combines some cryptographic methods, and it uses these cryptographic methods to develop a currency, a payment system. So it is a payment system. I can use Bitcoin to pay you right now, to send coins to you immediately. And the magic thing about Bitcoin is that there is no centralized authority, there is no such a thing like a bank or a financial institution that backs up the whole system. So it is a scheme that is completely peer-to-peer, and it is maintained by anyone in the world that wants to participate in the maintenance of the system. So as you might have already heard, we don't really know who is the inventor of Bitcoin. So the Bitcoin white paper, the whole system, was proposed by someone with a nickname Satoshi Nakamoto. We still have no clue about who this person is. It's probably he or she or they are probably billionaires right now, given the very high prices of Bitcoin lately. And the whole idea is based on something that is called the consensus protocol. So you can view the whole Bitcoin cryptocurrency as a large transaction table. So think that every single transaction that happens in the world right now, so if I send to Dora right now 2 coins, a transaction that will say Foteini sends 2 coins to Dora will be recorded in this public table that everyone can observe throughout the world. So the difficulty behind this protocol is who is the entity that maintains this table and who is the entity that makes sure that the view of this table is correct. And who is the entity that says that nobody can alter transactions or nobody can change the order of a transaction and so on. So in a traditional financial system, that entity would be your bank. But in the Bitcoin world, in the cryptocurrency world, as I said, this is a peer-to-peer effort. So this is an effort, this maintenance of this table is a public effort. And this is done through a protocol that is called a consensus protocol. And this is the technical beauty and the difficulty of developing cryptocurrencies and blockchain systems.
Right. So since it's decentralized, there's no room for corruption like a bank or a government would do, basically, because the actual money that we own it's actually controlled, isn't it, by the government, by a bank. Whereas with cryptocurrency, that's what decentralized mean, right? That's the meaning of
Absolutely.
decentralized.
Absolutely. So cryptocurrencies are completely free markets, right? So their price is defined by supply and demand, and there is no control at all. There is control on the number of coins, if you like, available, but this is something that is fixed and it is predetermined in the protocol. So whenever we think about Bitcoin or any cryptocurrency, we should think of it as a piece of software that is running in all these, let's say, devices of the people who maintain it. So this piece of software is a deterministic, it's a deterministic algorithm, if you want to think about it. And it defines how many coins are generated at any point. So when Bitcoin started, the idea was that it didn't start with a full supply, because this would immediately imply very low prices. So it started with a small supply, and the supply was steadily increasing with a specific mechanism. So right now, roughly every 10 minutes, new coins are introduced into the system. So where are these coins going? Who gets these coins? So this is an interesting part of the protocol. So remember that I told you that everyone can participate in the maintenance of the protocol. But why would someone bother to do that, right? So why would I bother to offer my computational resources to maintain a protocol? Okay, maybe, it's philosophical and I really like to support the system and I want to do that, and people certainly are doing this. But if there are really no incentives, the number of people that would back up the system would generally be small. So the way that Bitcoin was structured was in a way to actually give incentives to people to participate in this maintenance of the system. And these incentives were the newly generated coins. So whenever someone participates in this maintenance of the system, is eligible to receive the new coins that are generated basically every 10 minutes as the system is running. Okay. So remember this table that I mentioned before, where all the transactions are organized? So these transactions are organized in a very neat way. So new transactions are added every 10 minutes in batches, in blocks. Right. So whenever such a new block of transactions is added, new coins are generated in the system, and whoever was the party that puts these transactions together in the block and adds them in their protocol, in the blockchain setting through the consensus protocol, is the one that will get this reward of the new coins. Right. Things are slightly more complicated, and again, I'm happy to elaborate more, but that's a high level view.
Yeah. So it's funny you mentioned that, because I was reading about blockchain, and the actual concept of blockchain and the framework of blockchain, it's not actually a new thing. And it was there before Bitcoin. It's just so that Bitcoin made it so popular, right? So what exactly is blockchain in simple words?
So really, the thing that existed before is not really the term blockchain, but is the underlying mechanism of consensus. So in general, the problem of consensus, as you very correctly point out, is a problem that computer scientists have been studying since the 70s. And that this problem says, how can we have a set of parties agree on a value, on a specific value? Now, as this value, think of this table of transactions that I have been talking about, or more generally, if this blockchain system doesn't only cover transactions, but it wants to include more different types of assets, let's call it blockchain. Let's call this table the blockchain. The reason that we call it blockchain is because it's organized in blocks in a chain fashion. So every block is added after the other in a chain fashion. But this is kind of arbitrary. You can call it whatever you want. I think calling it a table is probably easy. So the distributed systems community has been studying this problem on how can a set of parties, distributed set of parties, agree on such a value, on such a public table. And this was a problem that was solved as long as the number of parties was small. And by small, I'm talking about like a dozen of parties, and as long as these parties were known to each other. And by known to each other, I mean that they had some cryptographic keys that they were, someone could check that these keys belong to these parties, and they could run this protocol together to agree on this common value. And here is where main evolution of Bitcoin came on the blockchain side, on the distributed system side. It basically allowed to run a consensus protocol among a very, very large number of parties. I'm not talking about dozens anymore, I'm actually talking about millions of parties, and solve the problem of known identities. So it said that now millions of parties can run this consensus protocol, this distributed systems protocol together without having to know each other ahead of time. So if we pause for a second and think about how these protocols look like, the basic idea is that they look like a voting process. So we have this large table and we're trying to agree, let's say that 100 parties are trying to agree if this is the correct view of the table. So what these parties could basically do would be to vote and take the majority of the voting. So if 60% of them agree that this is the correct view of the table, this is the view of the table that we should adopt. So the problem though is that if we're talking about digital identities, how do I even know that there are no symbols? How do I even know that an adversary is not creating a bunch of fake identities and use them to vote on whatever view of the table the adversary likes? So this was the big problem that people in the distributed systems community had a hard time to solve. So Bitcoin, exactly because it has this cryptocurrency, this currency notion tied along with the system, it gave it managed to close the gap here by transforming the way that parties are voting. So now every single party does not have a single vote, but the voting power of each party depends on their computational power. So the more computational power I have, the more votes, let's say my vote counts more in the system. And the question was, how am I going to count how much computational power does Dora has in her laptop when she's participating in the system? And this came via something that is called a hash puzzle, a cryptographic puzzle, if you like. So everyone who participates in the system, in order to vote about what is the current view of the protocol, they need to solve hard puzzles. And by hard puzzles, I mean puzzles that if someone tries to solve, the probability of solving them is actually tiny because it would take a huge amount of time to deterministically solve this puzzle. So there is a matter of luck on how fast someone will solve the puzzle. But if you assume that a large number of parties are trying to solve the same puzzle at the same time, then with good probability, one of them will solve it fast enough. And the party that will solve it faster is with high probability the party, some party that has a very high computational power. And of course, why would someone invest so much computational power into the system? Exactly because it has financial incentives. And if it is the party to vote and his view or their view end up on the table, they will get the newly generated coins in the system.
Right, that makes sense. Okay. So that is kind of like where Bitcoin and blockchain stands out. But the blockchain framework is actually used in business now, or they want to use it in the future in business, because everyone is talking about it. It's kind of like a framework that has big future. They're talking about maybe using it in medical records or voting systems, like you said. So what exactly do you think, what is the future of blockchain in business?
So first of all, I always like to place this bet when I'm talking about blockchain. So let's try and Google the term blockchain plus X, and on X put whatever you like. So I'm betting that some startup is going to be claiming to do blockchain plus X for whatever X is. Right. So it is really amazing that you see so many people interested in applying blockchain in different settings. In my opinion, in many of these settings, blockchain is useless. So we also see like a lot of buzz out there around the blockchain ecosystem and around blockchain can do. So I just want to say that we have to be cautious whenever we hear about let's use blockchain for X, because it's really not needed in many cases. So we do see many potential applications of blockchain, but I think the main characteristic that would make blockchain interesting in a setting is the following. So if you have a set of parties that they want to agree on a common set of values and they do not trust each other, then blockchain is a good approach. If you have a set of parties that they already trust each other and they just want to collectively maintain a set of a collection of data or some information, then blockchain is probably not needed. So why do people, for instance, say that blockchain could be useful in medical data? So let's think of the example of transplant lists. Okay, so think that you have a set of hospitals or transplant centers, and they want to share the patient list. So this is actually a very good example of different parties that we do not necessarily assume trust between them, and we want to make sure that the order of the patients that is added in this list is non-malleable. Nobody can go there and alter the name or change the order of someone. So in that setting, if they want to have this common list of patients without trusting each other and making sure that no one can alter the history, blockchain could be a very good setting. So we also hear about blockchain being used like beyond the whole currency, cryptocurrency world. There is this notion of smart contracts. I don't know if you heard of the term smart contracts before. And the idea of smart contracts is that, as I said, like blockchain, usually when people think about it, they think about payments and Bitcoin. But in practice, you can think like storing any type of information on the blockchain. And one type of information that someone could think of storing is actually software, it's actually code. So what a smart contract is a way to automate the execution of code online on this distributed setting. And I think, in my opinion, this is the most interesting aspect of blockchain that makes it very attractive in different types of businesses. For instance, like some sort of like contract signing, e-voting as well, and so on. So the ability to run this code, not having it run by specified third party, but on a distributed manner and with conditions that are publicly checkable. So think of a very fun application. So let's say that we want to have some sort of bet again, Alice is going to pay Bob $10 if the weather tomorrow in London is, like below 10 degrees Celsius. So if they wanted to do that in the real world, they would need some sort of third party to facilitate the bets and make sure that the rules are going to be enforced. But in the blockchain setting, they could just write this piece of code, which is a very simple code, put it on a blockchain that supports such types of assets, and then have it automatically run. So it can use any public source to check the temperature in London. And if it is actually, what did I say, below 10 degrees, then the coins of Alice would be automatically transferred to Bob. If not, the coins of Alice would go back to her wallet. So such kind of agreements, and you can think of that as like buying the house through this way, or you could think of this as having any sort of financial contract happening immediately on the blockchain.
Yeah, that is very, very interesting. All right. So we can see the good things and the advantages of blockchain. But I know that there are many disadvantages, or just because, it's just becoming such a big deal, there's things there that haven't been solved, right? Like it consumes too much energy, there's immutability in data. So again, I'm not an expert in this, and I've only started reading about blockchain the past couple of years. What's the progress in resolving those disadvantages?
So first, let me say that the research community has been extremely active on the whole blockchain space, and this is actually amazing. And not only the crypto community, it's one of the things that we have observed. So many ideas coming from people in online forums and stuff like that they're truly interested in how this technology works, and they're really honestly trying to understand the mechanisms behind it, and they're coming up with ideas. And some of these ideas, they have been great. So there are researchers that are picking up these ideas in like online forums and are writing papers out of them. And I also, as I like to joke about this, so crypto is one of the biggest crypto conferences, or flagship conference happening every year in Santa Barbara. So a few years ago, if you would Google the term crypto, you would always find this conference being at the top of the list. Right now, if you Google the term crypto, you will find something about cryptocurrencies and blockchain, and probably the crypto conference ends up on like the 10th page of the results. So this really shows a lot of interest from the general community about how these things work and try to solve the problems that appear. So if I was to try to organize what kind of challenges we have in the blockchain setting, I would say that, as we said, one challenge is power consumption. So we would basically need different consensus mechanisms. One challenge is scalability, and one challenge is privacy. So for me, these are the three main challenges. So let me say a few things about each one of them. So power consumption, as we said, the Bitcoin evolution was the fact that they managed to create this consensus protocol that is based on solving puzzles, is based on the computational power of parties in order to run consensus. So this is great. It solved a long-standing open problem in the distributed systems community. But as you said, it's extremely computationally expensive. So at this time, the amount of energy that is needed to maintain just Bitcoin, and think that there are like thousands of cryptocurrencies running out there right now, is about the same amount of energy that some small country needs to operate. So this is huge. And it is a hard problem to solve. How can we have this reliable consensus? As I said, it was an open problem for so many years. And now there are some other ideas as well. So one idea is that of proof of stake instead of proof of work, where your vote is weighted on the amount of computational energy consumed. Now the idea is that your vote is going to be weighted on the amount of stake you have in the system. So the more coins you have in the system right now, the more coins you own, the higher the weight of your vote is. So this protocol still allows to have a secure protocol, even in the presence of CBILs, even if an adversary tries to create fake identities, because even if an adversary creates fake identities, it cannot create fake coins, it cannot increase its coin supply. But there are other issues with such coins as well. However, we have a couple of big cryptocurrencies that are based on this proof of stake system right now that are employed and people can use. So this is certainly something that came from the research community, and it's certainly a possibility. So in my opinion, the proof of stake is the most prominent solution to the energy consumption problem, and where people are still studying the effects of it, mostly on the game theory side. So the second problem is that of scalability. So remember I was saying that, for instance, Bitcoin or any blockchain is organized in a block fashion, and transactions end up in these blocks. But there are issues with how many transactions we can fit in there. Have you heard at all about how many transactions Bitcoin can support per second? So the number is actually very surprising. So the number of transactions that Bitcoin can support per second right now, worldwide, is something between 4 to 6. This is a tiny number, because if you think the alternative, if you think the credit card networks like MasterCard and Visa, they can support around 46,000 transactions per second. So if we would say that everyone in the world wants to quit the typical credit card payments and use cryptocurrencies, then we see immediately that this is not possible. So solving scalability, again, it's not an easy problem, because again, just because the system is distributed and people would have to agree online about the values that are posted there, like routing a huge number of transactions makes the protocol very hard, makes the participants work much harder. So there are multiple solutions there as well. Some of them say, let's use sidechains. So let's kind of divide the world economy in smaller cryptocurrencies and have your local cryptocurrency for your, for your everyday purchases that you do in your local places, and have kind of meta chains on top of them for other types of transactions that you don't do that often. So this is one approach, just, divide and conquer. So another approach would be to just move some transactions off the chain completely. So if we know that the two of us are doing transactions with each other pretty often, we can move some parts of these transactions off chain and only use the actual blockchain in case that there is some dispute between the two of us. So this is another approach. use. And there are things like the Lightning Network that is doing something like that. So the third big challenge for me, and this is actually something that I'm mostly interested on the research aspect, is the issue of privacy. So I would like to take a second and think a little bit about privacy here and what happens with privacy of our payments, right? So let's forget cryptocurrencies for a second, and let's just think what happens when we make payments with our credit cards. Okay, so my bank knows right now how often I buy coffee, when do I go out to eat, where I go out to eat, how often I travel, which hotels I stay at, how much energy I'm consuming in my house based on my bills, and so on. So this amount of information is huge. And it does come with implications. So at least in the US, there have been cases where the financial information of customers have been leaked to insurance companies. And there have been cases where people were refused insurance based on the fact that their lifestyle is too risky, because maybe they were going out to bars quite often. So this is actually a very, very serious implication for privacy. And if we think again, the amount of data that we provide to financial institutions, it is insane. And let's think what was happening some years ago, right? When I was a kid. So when I was a kid, at least my parents were not using credit cards, they were paying cash. So what the financial institution would learn was maybe what their income is, maybe what was their monthly expenses in total, but they would have no clue about how people were actually spending their funds. Yeah. So what we have been trying to do for a while on the crypto world is to design privacy-preserving electronic payments. So be able to still use some credit card, but in a way that payments are privacy-preserving on the bank side. So in the way that our financial institution has no clue about how we're spending our coins. So we have been pretty happy because we actually have quite good protocols that achieve that. And then the whole blockchain thing started. And now we had the problem that our financial institutions knew our transactions, and now we have the problem that the whole world knows our transactions. Why?
Right.
Because these transactions now end up on this public blockchain that everyone has access to and everyone can look at it.
Right.
So in practice, in blockchain, in Bitcoin, for instance, you don't really see the names of the people that are doing transactions. You see some pseudonyms of them. And that's why when Bitcoin first started, people thought that, hey, this is the perfect means of payment for illegal types of transactions. So if I ever want to buy drugs and keep my name hidden, I can do it by paying with Bitcoin. So Bitcoin was massively used in
the dark web. It started from the dark web, no?
It did, indeed. So Silk Road was one of the most popular dark web marketplaces that was mainly selling drugs, and Bitcoin was the main type of payment that was accepted. And so Bitcoin started, becoming popular, like I would say 2011. And 2013, there was one of the first research papers that came out and said, look, the transactions on Bitcoin are not anonymous. We can actually use machine learning, basically techniques to cluster, to do like network clustering analysis and cluster together transactions that we think belong to the same users. And then using auxiliary information posted in other resources as well, we could actually concretely de-anonymize those users. And this research was actually used for shutting down Silk Road and other similar marketplaces in dark web. And in fact, today there are companies that their main business focus is de-anonymization of transactions in cryptocurrencies. So my point is that nothing is private in the cryptocurrency setting. Everything that ends up on the blockchain, you should view it as completely public and you should be aware of it. And it took a while for people to understand this. Like for many years, people kept on thinking that such currencies are indeed private. But now, again, we have some solutions on that aspect. So different research groups have been developing solutions for privacy-preserving blockchains, privacy-preserving cryptocurrencies, and even privacy-preserving smart contracts. How can we have code running on the blockchain in a kind of obfuscated way so that we don't know the participants, the values that are being paid, even the testing conditions. So yes, I think privacy is another very, very challenging part.
Wow, that was very informative. Yeah, nice. So one last question. Have you, like, I used to work in the gambling industry, and none of the programmers that works in the gambling industry actually gambles, because we know that it doesn't work. People shouldn't gamble, basically. But have you ever used Bitcoin in your like everyday life? Like, have you ever like bought coffee using Bitcoin?
I want to say a couple of funny examples on this. So the first time that I learned about Bitcoin was I was back in grad school. I was a teaching assistant in the network security class, and I was giving an invited lecture, and I had just learned about Bitcoin. And back then, you could get some small amount of Bitcoin for free, and like they were giving it out in forums. So I said, oh, this looks like fun. I should teach this to my students and give them out some small amounts of Bitcoin just to play around for class purposes. So if I estimate this correctly, if the students kept the amount that I gave them back then, they should have at least a couple of $1,000 each one of them. So I was literally giving them out thousands of dollars with current prices.
Nice.
So that was my first experience. So I haven't really invested in Bitcoin. I haven't really bought Bitcoin. I do own some from different resources for research purposes and donations and different reasons. It's been really tricky and very interesting. So people are using Bitcoin to buy stuff actually. So I have friends who are really into the cryptocurrencies world, and they try to make most of their transactions through Bitcoin. So if we go out for dinner, I have friends that would say, hey, can you pay my dinner and I'll transfer some Bitcoin to you? And I'm like, yeah, sure, whatever. Okay. So this certainly happens all the time. I also have colleagues that think I'm rich because I'm working on Bitcoin, which is certainly not the case.
That's mainly the reason why I asked you. I was expecting you to say, yeah, I actually own 2 million.
And the private jet, yeah, no. But, I mean, it's certainly, as I said, it's like a supply and demand system. The prices go up and down all the time. I'm interested on the research aspects of it, not the gambling aspect of it. But I would never advise someone to buy or not buy a specific cryptocurrency. So please make sure that this is not your next.
No.
I had quite a few fun stories with it.
Nice. Foteini, thank you so much for everything. It was very, very informative for me, hopefully the listeners as well. Thank you very much for your time.
Thank you, Zara. Thank you.